One of my big 85 watt daylight CFL bulbs that I use in the studio here failed on me. I had two of them, and one of them died like within a year or two, a couple of years anyway. Didn't last that long. Should have lasted a lot longer. Just went dead. I figured, okay, let's see what went wrong with it and see if we can make this thing light up again. It would be nice to be able to get this light back in service because it did give a nice light, perfect for filming under. Let's check it out. This is a 85 watt. It never drew 85 watts, but 85 watt, 5500 Kelvin, 110 to 130 volts. It's a large compact fluorescent that I used for one of my studio lights, and I had two of these, and this one here has decided that it does no longer want to work. In fact, the other one's not even on right now. I'll turn it on, but that should be bright as anything. I'll turn the other one on that's behind me. I don't know if it'll warm up, it'll add a bit more. I've got a couple of LEDs over the bench now, and that one identical to this is behind me. Anyway, I figured before I chuck it, I'll open it up and see if it's just something that's gone bad in the inverter that can be repaired, or is it the tube itself that's gone bad? It's probably the inverter. So let's open it up and take a look. Now, I don't exactly know how this comes apart, but I would imagine it probably pops apart here at the base. Which it does, just like that, and that reveals the, oh, look, it's, oh, I think this one's shot. Well, in addition to Puffy the capacitor, I should probably pull the other one apart and fix that before it goes boom. But yeah, we can see what's happened on here. This one's cooked. Its goose is cooked pretty good. Could it be fixed? Yeah, possibly. It possibly could be fixed. But as you can see, if you look at the output transistors here, well, one of them has a new inspection port. It's kind of blown into smithereens. So there's a good chance that in addition to, well, we know that this is blown, and that one's blown, and that cap there is blown, and I'm sure probably a bunch of resistors are also open. We can certainly measure and see whether they are bad or not. The one that's sitting behind me turned on probably should be checked to see whether the caps are failing on it, because certainly that is probably what made it blow up. Is these 33 microfarad 250 volt caps that let go, and that's likely what blew the inverter up. And as to how far the damage is on this thing, well, let's say we know for sure that one's bad. I'm sure this other one's bad. Let's just check some of these resistors, because I bet you there's a bunch of resistors that are open as well. So, in other words, a lost cause. But I will pull the other one apart. I should shut it off so that it cools down. I will pull the other one apart, and we'll check the caps that are on that, because if I can prevent it from going kaboom, then I will. But let's just check these resistors out and see whether these low ohm resistors are open, because I bet you there's some that are open, if not all of them. Yeah, that one's open. Go to oops, ohms mode here. 20K, yeah, I think that one's bad. And this one here is, that one's 2.3 ohms. That one's not open, but that one certainly is. It should be like a 10 ohm resistor, same with this one here. Here's another 10 ohm resistor here, and I bet is this one open as well? No, that one's okay. How about this bad boy down here? I can't even see the meter when it's sitting there. I gotta swing the meter around here so I can at least read it. That transformer could be damaged too if it's shorted out. if the transistors that are supposed to be switching on and off rapidly, all of a sudden one stayed on and to the point where it exploded, chances are it's burned the coil open. 2.2, that resistor is okay as well. What about this one down here? This one here is a higher ohm, so this one's probably fine. Yeah, 670, it's supposed to be 680, so that one's looking okay. Another resistor down here. This one is open. Yeah, so that one's popped. So there's a couple of resistors, and this transistor is totally, well, it's annihilated, as you can see. There's nothing much left of it. So this is not going to be something that is going to be repairable, that's for sure. Well, I mean, I guess it could be if you wanted to change out parts. I don't know what shape that transformer's in. For sure, there's a transistor here. I'm going to go out on a limb and say that this other one also is probably shot. I'd have to unravel the lamp leads here and pull the little circuit board out. Let's see if I can unwind these. There are wire wraps on here. The reason they use wire wrap is it's faster. You don't have to solder the leads down to the circuit board. The board would be screwed in place, the wires were brought up, and then there's wire wrapped, and it just makes for a very quick assembly. I hate wire wraps. We used to use them at work for some of the old DSL ports, the high density blocks as they called them. And they used pins, and you took your wire and you stripped back about 2 inches or so of copper from your jumper, and you put it in your wire wrap tool, a gun, stuck it over the pin and squeezed the trigger, and it would wrap your wires. Well, that was fine. It's just that when you had to do a port change, you had to unwind them and take them off. We had a tool for that as well. They were just a pain. I know that I didn't have to deal with it very often because that was central office personnel that dealt with them, but they didn't particularly like them. As one of the CO people that I used to know, who's long retired now, he said it was a bad joke that someone had come up with a better way of doing things, and it was the wire wrap. He says, no, that was if you're doing a permanent connection that's never going to come out, then the idea was good, because once it was done, it was, it was fairly robust. But the problem is, things change. People cancel service, order service, change service, do port changes, move, and all this stuff required that it be re-jumpered somewhere else. And that just took extra time. Okay, got the circuit board out now. There's a fuse over here. I'm sure it's probably blown. I'm going to remove the power wires so that I can work on this away from the base. Let's see whether the fuse blew. Did the fuse bother to blow, or did it just blow up other parts and go dead? Here's the fuse. Two ohms. My meter probe show 1.9, and this is measuring 2.1. So the fuse is okay. That resistor is okay. How about that resistor? That one's okay. That one's open. Nope, wait a minute. That's 680 K, that's okay. This one's open. 20K. It's supposed to be like, looks like 10 ohms. This one here is also open. You guys can't see the meter, but if you don't believe me, that's your problem. I'm calling out the numbers, but it is open. And that one should be 33, what is it? 330K. It's open too, it looks like. What are we measuring here? Well, I'm measuring half a meg, so orange, yellow. That one's measuring high. There's a diode here. It is okay. There's another diode over here. Well, there's a couple diodes. That one's shorted. Maybe not. That one's okay. Short here. Bet this transistor's shorted. That transistor shorted. This transistor here is going to be probably open because it's blown in two. So both transistors are bad. What's the number on this one? Does it even say? But it's a MOSFET 13005B. Anyway, if you ever want to see inside a transistor, well, we can remove it. You get a bird's eye view of what's inside this thing. From a failure standpoint. So what I figure probably happened on this unit when it popped was more than likely what happened is these caps started to dry up and ripple started to build up. Now this was installed in a fixture, an open fixture, but the top is closed. So the heat would have been building up. This one was pointing straight down in the overhead fixture. I'll show you the fixture it was in. It's in that fixture there, which has got these LEDs. As you can see, they got LEDs along all the sides as well as shining down, but it's got a nice reflector. That bulb was in that fixture. What would happen is heat would build up, heat from the lamp burning this way, heat would build up inside here. And I guess what it did over time was it dried up the capacitors, and then their ESR went high, which caused excessive ripple. And at some point in time or another, one of these transistors locked in the on state. How this is operating, it's basically the two transistors are oscillating back and forth. One is on and the other's off. They're just doing a square wave. Their MOSFETs are either on or off. And when one comes on, it'll create a pulse in this little transformer here, which will drive the other one on and drive it off. So one turns on, then it turns off, the other turns on, and so forth. And what that does is it takes the higher voltage DC, which is on these capacitors here, these 250 volt caps, 250 volt rated caps, be probably about 170 volts on here, DC, because the incoming AC is rectified with the rectifier diodes here. And these two transistors switching back and forth will then send their resulting output into this transformer here, which would step up or step down, step up more likely the voltage, that would then end up on the output terminals here, going through these capacitors. They're using capacitors to isolate and step up the voltage. So transformer has got, I'm just looking for the windings. There's one winding here, and then these two here are the primary. Looks like. I only see, I don't see a second winding on here. I see two terminals here and basically one terminal on this side. But they are going to the lamp. So one of these terminals is going directly to one side of this lamp. There's a diode across here to the other winding of the same lamp, the filament. There's a diode across there, and on this side there's a diode across here as well. And that's changing the AC to a DC signal through this diode to pump up capacitors, which are used to, again, to keep the oscillator running. I was looking for how the lamp is connected. The lamp is actually connected through this little transformer here on the ferrite bead, because the lamp is connected across here. The lamp is across here and across here. So these are each end of the lamp. This is the filament in the end of each of them. The heater is here, and across here is where the arc occurs. And that is basically through these two capacitors. Now one side returns through this transformer. They're actually connected together. One side of the tube goes through this capacitor, which ends up on the other side of the tube. And on this side, it's going through this little toroidal type transformer. Anyway, what usually happens on these is what has happened here. Capacitor opens up, causes excessive ripple. Excessive ripple causes excessive heat, and eventually something blows. So this is probably just fine. If I hook this up to a neon transformer, I bet it would glow quite nicely. If I put it on another ballast, it would probably light up quite nicely as well. But it's usually these that fail, and that is what's happened on here. This has failed. As you can see, when it failed quite violently. Takes quite a bit of power to blow one of these into pieces. This is basically the equivalent to your car engine throwing a rod. Voltage to smoke converters, as we called them. What I should do is I should take the other one that's operating behind me. We'll pop it apart and just see what the caps are, see if they're in the stages of going bad. It might be worth my while to swap it out before it goes poof like this one did. This is the other one that is still functional, and it's actually quite hot because I've had it on, and it is pretty warm. We'll pop the base off on this one and just see what those caps look like. Whether they're bad, I bet you they are. If they're not blown, I bet you they're starting to swell. Oh, they're not yet. But they're pretty warm. I bet you they're getting ready to blow. If you look at the transformer from the dead one, I think that's probably shorted. Look at the difference in the color of the winding. That's gotten awful hot. I bet you that's shorted too. That might have been part of the problem. It may have just overheated, shorted out the winding, and then blew everything else up. But these caps at this point have not started to bulge. That might have been because this was in a different fixture that has better ventilation at the back, although there's still a lot of heat that's going to build up inside here. These don't have much ventilation. They have these little vents here, but that's not going to drain away much heat. I'd probably be further ahead to punch holes inside this just to let the heat out of it, because this gets really, really hot. And heat, of course, is the number one enemy for capacitors and components in general. Even if we look at this transformer, I've got yellow, red, and blue wires. On this one here, they're all black. Yeah, it got warm. It got really warm. Here's another dead one. The difference is this one is it's old. This is a 42 watt. This one was installed in 2003. And you can see it's kind of melted. I don't know whether the burner went on this or whether it was the inverter. This one is glued together. I think I'm going to have to probably cut this one. So let me grab my cut-off wheel, my little Dremel. I'll use the battery-powered one. And we'll just cut into this one. I want to see whether the inverter is shot on this one as well. Or maybe the inverter's okay. And and I can light up that other tube with it. Oops, I cut through the wires. Got into that one pretty easy. As suspected, the lamp is open on one side. Filament is open, you see, that's just measuring skin resistance. That's one filament there. The other filament here is okay. So maybe the transformer is okay on this one. I guess I could try connecting it up to the leads on that and see whether it actually does anything. I don't know if the transformer is shot on this or not, but I guess we'll find out if I connect it up to the leads here. Alright, the moment of truth. I've attached the wires for this burner to this other ballast. I don't know if the ballast is any good or not. I don't have power to it, but now I have power to it, and we notice that the burner works, and it was just the lamp had failed on this one. So this one here, I can put this one back in service. It's got to figure out a way to attach this to this other burner and keep, or to the other ballast, and keep the wires from shorting out. So, but hey, I've just got another, you know, it won't be putting out no 85 watts. It'll be limited to 42 now. Probably last forever. But I fixed it. I got one working from two dead ones. Cool. I've just put some heat shrink tubing around the leads so that they won't short out against each other or anything else. I'm just going to see if I can throw some zip ties around the base here to hold it together. Got some small zip ties. It'll probably fail from the ultraviolet light, but oh well. We'll throw a few of these around here and see whether I can zap this together and put it back in service. Alright, will it be good as new? Let's find out. It's either going to light up or it's going to go boom. And it lights up. And that'll hold that okay. So I think I can reinstall this lamp and use it. There it is. Back in service. Now I get light on this side of the shop again. So there, you learned something today. Sometimes when these things fail, it's the ballast that goes bad. Other times it's the burner. Say this one here was installed in, this is one of the original ones that was installed when this place was built. So 2002 was when this garage was built. And I had 3 of these in service. This is the last one. The other 2 died. Well, actually, 2 of them failed relatively, well, one failed relatively quick, and I contacted the manufacturer and they sent me 2 replacements. And another one failed, and I just had to resolder connections on the board that went bad. And I had that one for the longest time just hanging by its wires. This one was the 3rd one that finally died. I've got 2 more because they sent me 2 replacements, but I haven't got to use them yet. This one here, the electrode failed on here and burned out, but the ballast was still okay. So I took the ballast and, well, put it on that other lamp that this one failed on, and you know, it's only 42 watts versus the other one. It's supposed to be 85. There's no way in hell they were 85. They weren't bright enough for 85, but it still gives off a fair bit of light, and it balances the light on the left side of my bench. So it's going to stay in service in one of the ceiling lights there until it dies. But that's what we try to do. Try to recycle when possible and get the maximum use out of these. This tube is gone now, so it can be recycled. But I hate recycling them if it's just a bad ballast. Always grab another ballast out of another one and swap it over. They usually are compatible with each other, as long as you don't go bigger, right? If you have a 25 watt, you can throw a 20 watt ballast on it. It'll put out 20 watts of light. But this one here looks to be, it's putting out a fair bit of light, so I think we're okay. And it should last for a while. Anyway, thought you might enjoy looking at a couple of these big, like 42 and 85 watt CFL bulbs. Now that CFL bulbs are becoming a thing of the past, everything's going LED now, so still got a few of them running here. They'll all run them until they drop, and then they'll be switched over to LED. Anyway, thanks for watching. Bye.